it happens quite a bit. And this evening into tomorrow begins the Jewish holiday in Hebrew called Tu B'Shvat, the birthday of the trees, or the Jewish Arbor Day. It's a strange thing because here in the States, it's obviously still pretty cold and it's wintertime. Over in the land of Israel, the very first almond trees are just beginning to blossom, and it is a time where I guess they don't have groundhogs there, but they have these almond trees to give the first signs that spring is coming, and it's a time of celebrating trees, fruits, nuts, so you have a little nosh on your tables. But the truth is that in Judaism and in all of our faith traditions, thinking about our connection to nature, to the environment, is not reserved for just one day a year. In fact, all you have to do is read the very beginning of the Hebrew Bible, those opening chapters which talk about the creation of the earth, to know that there is an important responsibility and connection that we as humanity have. In fact, spoiler alert, there are actually two creation stories at the beginning of Genesis that you might or might not be familiar with. I won't give a whole lecture about it right now, but they are, in fact, a little bit in tension in how they lay out that relationship. In the first story of creation, the one that we typically think of with 6 days, starting with let there be, I'm just making sure you're still paying attention, let there be light, right? And then the waters part and the land and the animals, and finally humanity is created on that 6th day and told, you are the masters of all of this. Go dominate the world, build, grow, and we're empowered in a certain sense to do what we will with this earth. But the second creation story that follows right after is the one where we read more specifically about the creation of Adam and Eve in the garden. And in fact, the name Adam comes from the Hebrew Adam, from Adamah, which means earth. In that second chapter of Genesis, God scoops up some of the earth and fashions from it the first man, places Adam and Eve in the Garden of Eden, and turns to them with a slightly different tenor, saying, you're here to till and tend, to protect and guard this planet Earth. God doesn't say earth exactly. And this notion of stewardship really dates back to those initial chapters of Genesis. So we are here on this birthday of the trees, to think about how can we, in the spirit of Genesis 1, continue to build and grow and create in our human ways, and also with the values behind Genesis 2, how can we do so in a way that is most likely to protect our environment, to preserve our climate, to do whatever we can to ensure that for our children and our children's children, the earth is still a beautiful, thriving place. So we have a wonderful panel of experts. I am not one of them, but I'm delighted to introduce 4 individuals who are going to share a little bit of their expertise and help take these sort of ideas and these values and talk really practically about how we can build and renovate in a green way. So I'm going to say a few words about each of them now, and then they'll all have a chance to talk, and I believe there'll be a Q&A after that. Am I right? Yes, I'm getting nods. Great. So first of all, I want to introduce, in the yellow shirt at the end, Dan Colbert, who had his bar mitzvah here at Larchmont Temple in 1977. Mazel tov again. He's been a contractor in Portland, Maine for over 20 years and a carpenter for 35. And for over a decade, Dan has moderated a local building science discussion group, the results of which were recently published in a book he co-authored called Pretty Good House. His company, Colbert Building, specializes in energy and resource-efficient new construction and renovations, and their work has appeared in Dwell Down East, the Boston Globe, Journal of Light Construction, and Fine Home Building. It's a little bit about Dan. I'm jumping around here. Third over to Liam Winters, who many of you might recognize. He is an architect all around town here in Larchmont, a graduate of Mamaroneck High School. You didn't have your bar mitzvah here, but you're still a local. And I know after studying chemistry and aerospace, you ultimately turned to architecture, pursuing a master's in architecture at the University of Texas. Liam started his firm, William G. Winters Architect PC, in 1996 and has been working with a base of clients in New York City, here in Westchester, upstate New York, Colorado, the Bahamas, Florida, and Vermont, to name a few places. Historic preservation, sustainability, and promoting better building practices on all of his projects have been a focus of his work. Next, in the middle of those two, is Judd Alley. Am I pronouncing that correctly? Well, say it better. Ailey.
Everyone says Allie.
Well, so you got to educate us. Judd Ailey, who in 1996 founded R.J. Ailey Building Contractor LLC, works in residential construction firm that specializes in renovation, repair, maintenance, and energy-efficient upgrades, especially for pre-1945 homes. I live in one of those. How many of you do? Judd is an NAHB certified green professional, a lead home builder, and a second-generation builder. He has an AAS degree in landscape design, a BA in history and art history, and lives in the historic village of Village Creek in South Norwalk, Connecticut. He is a past member there at Village Creek of the Architectural Review Board and a current board member of both the Norwalk Bike Walk Commission and the Norwalk Parking Authority. If anyone ever runs into trouble up there with a ticket, call our new friend Judd. And finally, I want to introduce Lauren Broyce, who is the director of the Energy Smart Homes campaign here at Sustainable Westchester. She works to transform local uptake of residential clean heating and cooling options and to support the goals of New York State's CLCPA. Since 2013, Lauren has worked on community-based approaches for helping us homeowners realize energy savings while making our homes more comfortable through energy efficiency and heat pump improvements that are incentivized. She is also a member of the Bedford 2020 Advisory Committee and involved in many sustainability initiatives here across Westchester. So a huge thank you to all of you for making the time. We're delighted to have you with us. Thank you, thank you. And I'm going to pass around the microphone to you all, I think, to speak in that order.
Thank you. All right, I'm going to come down here so I can see my slides. Different mic, or do I have a... This is my first time speaking at Larchmont Temple since my bar mitzvah. I can give my bar mitzvah speech again while we're waiting. Hey, that looks good. Okay, as I said, in a shameless self-promotion, I've got copies of our book, if anyone's interested. Next. We already talked about this. The rabbi mentioned this. Briefly, the book that we wrote and what I'm going to talk about grew out of this discussion group, local contractors and architects. We spent the better part of a decade talking about these ideas. Yeah, you can keep going. And in fact, skip the next one. We sort of call it an anti-rating system. We're really talking about why we want to help contractors, designers, and homeowners understand the building science behind better building. I'm a contractor. My 3 co-authors are all architects and designers, and we are, very concerned about the pretty miserable state of home building and home renovation, especially from a environmental standpoint. And I'm going to focus in today on the carbon piece of all of this, which seems like the most critical element. Next. Mostly, obviously, the upfront carbon all comes from the things that you put in your house. Next slide. This slide is a very simple, obviously, 2 very simple shapes, but there's a lot going on here. So this moment is when the house is built. The gray rectangle is the embodied carbon emissions. What that means is everything that went into the house, into building the house, everything up to the moment where the client occupies the house, and also everything that went into producing all those materials, right? Everything from the extraction to the production to the transportation. So on day one of the occupancy, all the carbon emission, all the embodied carbon is present and continues at steady state for the lifetime of the home. Obviously, on day one, there are 0 operating emissions until the clients turn the lights on. It hasn't used any power. So the reason why it goes to 2120 is because there's this world of carbon accounting, and the standard number, the carbon accounting basically means what are the lifetime emissions of this product or this process, and the term that is used, the length of time that is used, is a century. Unfortunately, as we all know in the room, we don't have a century, right? We need to get on, well, we're already too late, obviously, for a lot of this, but we don't have a century. So what we're really looking at is a very short period of time, and you can see, I mean, there are no numbers here, so we don't know what the scale is really, but it doesn't really matter. In the short term, you can see that the emissions that have gone into building the house dwarf the emissions that are used to occupy the house. And it's the short term that we're really have to deal with. Next. So the things to think about when you're actually working on either a new house or renovating a house is mostly what are the materials that you're using, right? What is the upfront carbon emissions? What's the content of them? How efficiently are you using these materials? And also, because you have to live in this house, what's it doing to the indoor air quality and the health of the home? We'll talk some more about all these products in a minute. Next. So one question is how far to go, right? This is a question we talk a lot about in the book. So this graph shows you, whoops. This graph shows you, you know, every inch of insulation that you put in. The first inch of insulation does a lot. The second inch does a fair amount. And then it's this calculus curve that, you know, every subsequent inch does less and less and less. That doesn't mean you should stop at 1 or 2 inches, but it means that you need to think about this as you go along, especially if your insulation material has high embodied carbon. The payback on some of these products, like especially foams, can easily be in the tens or hundreds of years, right? Before the amount of time it takes to save enough energy to pay off the carbon debt from producing the product in the first place. Next. So this is just a graph. There's a lot going on. Don't worry about it. But basically, you can see we're going from, in terms of environmental impact, you've got wood fiber and cellulose at the top, and then it goes down through various synthetic products, and then at the bottom are some of the foams, both the sprayed-in foam and the one of the types of the board products. The essential element here, there's other issues too. There's toxicity, blah blah blah. But you know, the essential element here is that, as is probably obvious, things made out of agricultural products are better. Especially agricultural waste products. Again, some of these guys, I mean, in addition to being toxic and being really bad for the people who install it, again, the payoff is forever. Next. I'm plugging a product that's recently is being produced in Maine. It's called Timber HP. We have a lot of underused wood products in Maine. You know, the paper industry is pretty dead, and we have a lot of empty paper mills. So some people I know started this company basically to produce wood fiber-based insulation products. They are working on 3 different products. One is a blown-in cellulose, but it would be raw wood fibers. And then there's some board stocks, and then there's also like a batt insulation, like a fiberglass. So next, I guess. Anyway, you can read that yourself if you want to, but you know, we are basically saying that you can take, you know, the trees that we're making of are storing that carbon, right? They absorb the carbon, and then if that wood fiber is not allowed to either burn or compost or whatever, then that carbon stays stored until something happens to the wood fiber. And so if it's locked up in an insulation, that's wonderful. Next. Yeah, this is basically what I just said. We can skip that. So you can see this is talking about the CO2 equivalents in various products. And you can see that that XPS, which is one of the board products, is off the charts. And wood fiber is actually a negative, right? It's a net negative. There are other products as well. The best things to use from a carbon standpoint are agricultural waste products that would normally either get burned or left to rot in the field, rice hull, things like that. Next. There's another tool I just wanted to mention briefly if you are doing any work or if you're a professional, that it's called the beam calculator. Some people I know recently developed this. It's a remarkable tool. It's basically a very complicated Excel spreadsheet, and they've taken what are called environmental product declarations, which manufacturers put out to talk about what's in their products. They've made this phenomenal database of products, and what you can do is take your house, enter the assembly, how much wood you're using, what insulation type you're using, what's your roofing, all of these things, and it'll spit out some carbon numbers for you. And, I wouldn't get too wrapped up in the accuracy, but the beauty of this is that it allows you to plug in and say, all right, if I substitute, this type of insulation for that type of insulation, what does it do to my total carbon load? So this is really, I can't praise the people who put this together enough. In fact, I have a book I'll pull out later by one of the authors if anyone's interested. Next. Yeah, this just talks about the methodology, life cycle assessments. We can skip that. Skip that. This is just a basic wall assembly for new construction. The one thing I just wanted to mention mostly in this is air sealing is really critical, especially if we're going to be talking about older homes. It's often very hard to insulate. You either need to tear off the outside of the inside or drill a bunch of holes to insulate. It's important to insulate, but there's two things to know. One is if you can't, then air sealing still makes a huge difference. And the other thing is if you insulate without air sealing, it's very easy to get your house in trouble. So this shows, in new construction is very easy to air seal, right? You see, if you've seen houses like with the green plywood with the tape on it, that's a very easy way to air seal a house. But in older homes, it's very tricky. Next. There's a new product on the market. I have not had a chance to use it, but I think it's got a lot of potential. It's called AeroSeal. Aero Barrier is the house product. It started as a way, somebody developed this as a way to seal up ductwork, where they were basically injecting this acrylic aerosol into the ducts and then pressurizing it, so it forced its way into any cracks and sealed it up. And then at some point they realized we could do it with a house too. So basically what they do is they set up these sprayers, they pressurize the house, and the acrylic forces its way through. And they set it up to a computer, and they can guarantee, you can keep it running as long as you want to get whatever level of air tightness you want. So certainly if anyone is doing, an older home that you have the opportunity to empty the place out because it makes a bit of a mess, it's a really fantastic opportunity. Again, I have not used it, but it seems like a very promising technology. Next. Yeah, you can see there, this is it. Yeah, and it's done. It sets up in 30 minutes and then you can start working. Next. So again, a plug for the book. It's not a how-to, it's a why-to. We're very much not, all four of us authors live in southern Maine, so we have all of our education is based in that part of the world. So what we have to say, we have zero expertise in the mid-Atlantic or southern states or whatever, but the building science is the same. So we're trying to say if you have not considered these issues, you need to. And we have a website. Next, I think that might be it. Yeah, and this is just the table of contents. So in conclusion, this is the last slide. There are two variables, carbon and time. We've exhausted both of them. So this is the worst moment in human history to be putting more carbon into the atmosphere. So unless your project pays off immediately or in the incredibly near future, it's counterproductive at this moment, right? It's counterproductive to weatherize your home if it's going to take 50, 60, 100 years for it to pay off. But we have better and better methods for doing so. Air sealing is low intensity and has a huge payback. Smaller and less complicated is almost always a better answer. And then finally, especially if you're the homeowner, is ask questions. These days, there's information everywhere and good information everywhere. There's really no excuse for practitioners not to be well educated on this stuff. That's it. Thank you.
Okay. Thank you. Anybody familiar with buyer's remorse? Okay. Same slide, please. Nope. There you go. I didn't know that picture was being taken by my wife. This is moment. Sorry. How's that? Oh, sorry. Magic. My wife took this picture of me unbeknownst. We had just signed a contract on the house, written the checks, all the rest of it. And contractors had come through with me to talk about rehabbing it, and they wanted nothing to do with it. It was 200 years old almost, and in really bad shape. Nothing could be salvaged, lots of toxins, lead, asbestos. So the only option was to knock it down, which was, I was ready for it, but so I formulated some designs that I wanted to work on immediately in a panic. I had signed up for a passive house class to take several weeks before that, and the class was coming up. And I went to it, and it immediately showed me everything not to do when you build a new house. Absolutely everything not to do, just like you talked about. No inside corners. What's like you want long exposures on southern side, places like that. Okay, and the design I came up with was the complete opposite of it. So this is what they want to do. They want lots of insulation, airtight construction, high performance windows, and this is, the next slide please, what I wanted to do, okay? So it's kind of like, here's a piece of a barn, here's a piece of a barn, here's a piece, and here's another one. So I took 4 rectangles and smashed them together and tilted a couple of walls, non-orthogonal, to make it more interesting. We back up to a gas station on one side and across the street from a restaurant with a lot of traffic near the schools on Boston Post Road. So I thought people would be okay if I made it kind of a perfect little place for us to live in the backyard. Next, please. So that was the intended design. Next. And that. Okay, so during lunchtime of day 1 out of a 6-day course I'm taking on Passive House, I showed this design to the instructor and said, can we do this? And he said, not likely. Okay. I said, but can we do this? He goes, yeah, we can do this. I said, great, you're hired. So I hired him. Do you know BLD from Brooklyn? Okay. When the course was over and I passed it, I hired him because I did not have the time to be an expert on all things to help me out with it. So he took every little nook and cranny in here and modeled it. And next slide, please. That's where we were. This is where we had to get to. And that's where I got to. So realized right away that the diminishing return of insulation and other pieces like that, you know, you can have 5 pieces of glass in your windows. That's not going to get you closer to what you need. So I went with 3 pieces of glass as a passive standard, and we got really, really close. And then we did with blower door tests, things like that, to try to reduce the amount of square inches that we were leaking. At one point, we were about 24 by 24 inch. That was the equivalent that was measured. We got it down to 8 by 8 inches, and we needed to be 6 by 6. And there was no way it was going to happen. It was going to take another month, and we had to move into the house at some point. Next, please. Okay, what is this slide? Overall energy use, this was modeled, and this is where we want to get down to, right here. So we're way off on everything. So I hired an HVAC company to come in, and since there's no BTU load of 9,000 available, like that would pump air conditioning and heating at that load, most of them come in the 100K range. That's pretty low, actually, right?
I mean, they're getting smaller, but 9,000 is very low.
9,000 is very low. So we have to be very careful about it, because if we didn't modulate it down, it would start raining in the house with humidity, because you have to take humidity out. So next slide, please. These are the windows that we used. The great thing about them is we can tell right now that they need to be tightened up, because we can hear ambulances on Boston Post Road go by. We can hear a door slam across the street as someone's leaving from Lenny's. But that's okay, it's kind of a dull sound. Next. Okay. So the orientation of the windows, their exposure, I saw the houses that you work with, you put overhangs everywhere. We're supposed to do that, and I'm going to do that, but we still haven't finished the house 7 years later. Next, please. And then winter shading. You actually want the sun to come in and help heat up the house. That's an ideal situation. So you can't have both at the same time. So I kind of had to limit the southern exposure because it really overheated the house. Next, please. Okay. So this is wall with insulation. This is a foundation with insulation on both sides. Next slide, please. What we ended up doing, we're creating 3 walls. Interior wall right here, which is where all the plumbing, electrical goes, and then you stuff it with insulation. This wall right here is not touched by anything. Nothing penetrates it. And then the outside wall, outside of the sheathing, is rigid insulation, and then you put your siding on top of it. So the idea is you get really high insulation value, relatively, I mean, it's labor, but it's not expensive. That gives us a lot of high performance, and then you have to wrap all this everywhere. Insulation is wrapped all the way through the house. So there's no points where coldness is able to get through or heat leak out. Next. Just a whole lot of paying attention to the highlighted. Contractors were really excited to be on board, and they've started to do all the same details here as they do in just regular houses. No one's asking for it, and they're taping everything, which is really cool. They are more expensive than everybody else. Next, please. Okay, and this is a real picture of how the taping, penetrations like this, the attention everything gets. And you do that everywhere in the house as it goes through the roof and it goes through the sides. Next. Next. Forget about that one. Keep going. Okay. Because the house is so tight, we do not have a chimney. Passive houses are not allowed to have fireplaces because you'll basically asphyxiate. We don't have candles. We don't have anything because it really does impact the way that the house heats up. When people come into the house, this is called an HRV. It brings in fresh air from outside and takes out all the air from the bathrooms, the shower, the laundry room, the kitchen. We don't have a hood. So the hood is essentially 3 hits on top of the cooking area, and that takes out all of the extra heat that builds up in the house that we need to get out. Doesn't take any grease. It's 10-foot ceilings. So it's really interesting, but we're able to put it on hyper mode, hit the button, and when we have like 20 people over, we don't want to open the doors if we don't have to. And we just turn that on, and that helps get more fresh air in. But what happens is at night, we sleep better, because we're getting all the fresh air. And if we close the doors, we have to have an undercut bottom of the door so that the air can circulate back to the returns. So it's actually nice. And when we go to hotels and places like that, it's always disappointing because we wake up feeling a little crappy. Next. So this is the foundation. Basically, we used Fox blocks, which are like great big pieces of Lego foam. They go on the outside, and they weigh nothing. In fact, the back of my pickup truck, I got a big trailer, and went upstate and picked up like 300 of them. And then 4 people and I laid all these out according to the surveyor's location, and then we poured concrete in, and all the foam actually just stays right there and becomes part of the house. So, next. Here's the wrapping on the outside. Everything is heavily taped. Next. Installation of windows, and then exterior sheathing, insulation. And then next. And this is the nearly done house. And it's really interesting because about a month and a half ago, a new client of mine introduced me to your book. I didn't know anything about it. And I immediately went to Amazon, picked it up, read it, and I was like, damn, that's what this is. Basically, it's a pretty good passive house. So I'm not accredited in passive house, and I understand the need for it, but I'll let those people do it because it's so much work that I'm not interested in going that far to try to work that. And we're pretty happy with this house. So with all the work that I do, we do try to apply it to every job, even if it's not really, the money's not there for it. Best practices. Oh. Yes, it has solar panels. That was the first thing we did because we have a flat roof up there. The roof is metal and it's recyclable. So that's the other thing. This wood, I don't really enjoy painting houses. I don't like the idea of it. So we have almost no paint on the house. And this is a wood that is kind of experimental, but I think it's pressure treated in cooking oil and sewage. I mean, it's really weird. And it smells really bad when you put it on the house. But bugs don't go anywhere near it. Birds don't go anywhere near it. No one, and it's, what's that? Kids don't go near it, yeah. So, and it's working so far.
Let's keep going.
Yeah, better. Next, please. Okay. I'm done. Okay. You're up. Sorry.
Next slide, please. I'm going to talk about reducing air leakage in your existing house. Here's a diagram courtesy of Fine Home Building. Typical. Yep, the mic up. Is that? Okay. Okay, how's that? All right. Typical house built in the last, 7,500 years, leaks lots of air down through the basement at the foundation to wall framing connection, through the existing windows. If you have recessed lights in the attic, in the second floor ceiling, you probably have a lot of air leaking there around the heat registers in the ceiling. These are all places of air leakage, and before you get into insulation, you want to control and reduce the air leakage as much as possible. Next. Most of the houses I work on have single pane wood windows. It's surprising how many of them don't have storm windows. If you have single pane wood windows, one of the simplest and easiest things you can do is buy storm windows and put them on. As opposed to putting in brand new windows, which your payback time on brand new windows is 20, 30 years, if that, So contrary to what the window companies tell you, it's really long-term. Next. And don't forget storm doors, traditional wood storm doors or aluminum, which are a little more, less maintenance. Next. This is a window of a house built in 1747. We added what's called spring bronze weather stripping to all the windows, and it dramatically reduced the amount of air leakage and the comfort of the house. Next. And here, 2 more photos of spring bronze weather stripping. This is partially installed here. The window sashes out. Here's where it's fully installed. This here is where the window slides up and down in, and you can see it's kind of bent up. That's the spring action that rides against the window and seals the air out. Next. Now I want to talk about basements. This is, at least everybody, I call this a bulkhead door. I think it's a familiar image to everyone. Next. I see a lot of basements like this at the bottom of the bulkhead doors. There's no door whatsoever, much less an insulated door. Also, in a lot of the houses I work on, they're still heated with oil-fired boilers or furnaces. Sometimes they're hot water boilers, sometimes they're steam, and they throw off a lot of residual heat that in a basement like this is going to go right up that staircase. Next. So a really simple thing that we do, and it makes a huge difference, is we build an insulated door at the bottom of the bulkhead stairs. It's typically 2 to 4 inches thick and has weather stripping on it. So here's that door closed. And next. Here's another example of a different job with another insulated door here and the weather stripping. Next. Now I want to talk about what's called the rim joist and the sill plate. This is the rim joist here. This is the sill plate. The sill plate sits on the concrete block foundation or on the concrete foundation. And in older houses, that's a big source of air leakage. Often, when I go into an older house like this, you can actually see daylight coming through. Sometimes there's English ivy growing into the basement or something like that. So we want to address that air leakage point. Next. Here are 2 examples of how we sealed up the sill plate and the rim and insulated the rim joist. Here we air sealed the sill plate to the foundation with caulk, and then insulated the rim joist with a material called Roxol. It's a recycled material. And over here is closed cell foam. I am not fond of foam products at all. I try and stay away from it just because of the environmental impact. So, next. Here's another basement. You can see there's insulation in the ceiling, and I see this all the time, and probably seems like a good idea to most people, but now that we're keeping all that heat down there from the boiler with that insulated door and sealing the rim joist and the sill plate, all that heat is sitting up here, and this insulation is actually keeping it down in the basement. And then the other thing that most people don't realize is it becomes a great mouse motel. And they don't pay for the use of the motel. But they also love to use it as a toilet. And, you know, if it's up there for 20 years, it's really disgusting. So once we seal up the basement like that, we recommend taking that insulation out of there, and that heat just rises up to the floor, and people often notice it. So, next. Now I want to move up to the second floor ceiling, floor of the attic. Everybody probably knows what this is, a recessed light. This is looking at a recessed light with an infrared camera. This is all air leakage coming through. This type of light, there's just cold air will pour down there from an unfinished attic above. You go up to the attic. This is typically what it looks like if you push the insulation back. You can see it there. There's just some thin sheet metal keeping the air from leaking through, which it doesn't really do. So to address this situation here, there's a product called 10-mat hoods. They're readily available at Home Depot, and you just drop it over the recessed light, and you can seal it in place with some fire-resistant foam out of a little spray can. And if you do that with all your recessed lights, it can really make a big difference. Next. Sometimes you may have a cathedral ceiling and you're not able to get behind it. There's no attic above, so you can't put one of those 10-mat hoods over it. A simple solution to that is you get these LED retrofit kits, and you can see here, thank you Home Depot for this nice photo series. You can use one of these and they really reduce the air leakage. I don't know if you can tell here, but this is really just one piece, and it just fits in there, and it's got a gasket on it, and it can make a big difference, and it's an easy fix. Next. A lot of people have pull-down attic stairs. Again, another big source of air leakage, and one of the solutions for that are these zippered hoods. The R value of these is not great, but it does help reduce the air leakage. There are also these foam boxes you can put over it. You're going to reduce the air leakage and get a better insulation value. Not shown here is maybe you have a walk-up attic stair. If that's the case, you can build an insulated door like I showed you earlier in the basement. So, next. And here's an attic, kind of a before and after. If you have heating and cooling equipment, ductwork up in your attic, and it's not insulated like this, most of this ductwork is incredible how much it leaks. I mean, it's amazing when you go up there. Leaking ductwork like this is often a cause of ice dams in the winter because it melts the snow high up on the roof and it runs down to the eaves and freezes up. So this can be fairly costly, but a solution to that is we insulate the whole attic ceiling instead of the attic floor. And now all this ductwork and the heat that it may be leaking off is trapped in the attic, and it'll lower utility bills, help prevent ice dams. Houses that are typically very dry in the winter and people run humidifiers. When we've done this type of thing, all of a sudden the humidity just from cooking and showering is now trapped in the house, and the house becomes much more comfortable overall. Next. And this, if you have an old house, a lot of older houses have no or very little insulation in the exterior walls. And a way to fix that is with what's called blown-in cellulose insulation. So they'll remove a piece of siding, drill some holes, and then there's a special truck that comes to the job, and they put this bale of cellulose insulation into it, and they blow it into the walls. It does typically a pretty good job. Next. And this is what it might look like inside the wall after it's been filled with cellulose, minus the sheetrock, of course. So, next. You don't always have to do everything at once. You know, insulate where you can. In this instance, the homeowner called us because they were having the house painted, and the clapboards or the siding that was here was so ancient. I think this house is about 1760, that the painter said, well, I can't paint that, get somebody here to replace it. So we came to replace it, and we saw that there was no insulation, so we took that opportunity to add a little bit. It's not a lot, but every little bit helps. Next. I just want to talk about oil-fired heating equipment. This boiler over here is from about 1958, and it looks its age. This is a much newer boiler. This happens to be a steam boiler. That's a hot water boiler. So how many people think we should get rid of that thing and put a new one in? Fair amount. That's understandable. Next. If you run an efficiency test, a combustion efficiency test on a boiler, you can see really how well it's doing. And this boiler, even though it's horrendously ugly, was running at 78% efficient. This much newer boiler was running at 84% efficient. So that's a 6% gain. And, you know, I think ultimately, if you're going to stay with oil, yes, you might want to replace it. But before you spend that $10,000 to replace this, put all that money into insulation. Next. This is a combustion efficiency tool. And every year, you probably all have your boilers tuned up. The oil company comes out and they do things and stuff like that. A lot of times, the technicians won't use this at all. They just do everything by eye, and they can get it close, but I would encourage all of you to insist that the technician does a combustion efficiency test and gives you this little printout. It tells you how it's doing. If the technician says, oh, I don't need that thing, say, I don't need you, and ask for a different one. You can see here the efficiency of this boiler was at 82.3%. You know, if you got one of these and it said it was running at 72%, something's wrong. It's usually a matter of internal cleaning of soot and things like that. So I think this little report that this machine will spit out is very important. Next. 2 different types of radiators here. A lot of people have radiators. Okay. This is a hot water radiator, and this is a single pipe steam radiator. With a hot water radiator, a simple thing you should try and do every year is bleed it. Maybe some of you do that already. You can go to a hardware store, you get a little thing called a radiator key, looks like an old roller skate key, and you turn the heat up, and you open up a little valve there and let all the air out. On a single pipe steam, which is the systems that I'm most familiar with, there's an air valve here, and I would recommend that these get replaced every other year or so. They're relatively inexpensive, and they're key to the function of these radiators. The steam comes up the pipe, and if it can't push the air out that's in there, then that steam is only going to stay down low. So these are really essential to the proper functioning of this. And don't ever let the painters paint those, because if you do, they're going to not function as they're designed. Next. Water heating, heat pump water heaters. I think, did you talk about that earlier? Okay, well, great product. They use 2 to 3 less times the energy of other types of water heaters. 1 more minute? Okay. I think they're great, and they basically, in a nutshell, they work like an air conditioner in reverse. So when they make hot water, if they're down in your old house basement that maybe has a stone foundation and it's really humid and damp, it'll help dehumidify your basement at the same time. Next. This is a wastewater heat recovery device. What happens here, when you take a shower, the water coming out of the shower head may be 100, 110 degrees or something like that. By the time it gets down to the drain, it's 80, 90 degrees, and all that heat typically is going out to the septic system. With a wastewater heat recovery device, this is cold water coming in from your well. It's a copper pipe around the drain line, and if you just remember that heat will always move to cold, so the heat of the wastewater going down moves to the cold water here, and the water going into your water heater is preheated. We have one of these in our own house. These are gauges that I put on ours, and you can see, I think this was in February, about 10 years ago, the water coming in from the city of Norwalk was 40 degrees. After it went through this device, it was up to almost 70 degrees. So it's preheating all that water and saving you a lot of BTUs. Next. These are, if you have a forced air system, I call this a circulating thermostat, And what it does is about every 40 minutes, it turns on the blower fan, and it's great for sort of evening out the hot and cold spots in an old house. Next. And I think this is my last slide. Just a word about the free energy audits and the companies that do them. A lot of them are very well-meaning, honest people. Some of them have salespeople who work on commission, and they're more interested in selling you a product than a solution. Does anybody know what this is? Well, this is an air conditioning unit in an attic. So there was a pull-down stair, and I stuck my head up, and it was about 30 feet away, and this is 3 feet of blown-in cellulose insulation. And the homeowner was very proud. He wanted me to go up there and said, yeah, I had my attic insulated. There's 3 feet of insulation up there. And I looked and I said, well, that's great, but your air conditioner, when it's time to change the air filter, how are you going to get to it? So we actually vacuumed this all out and then insulated the roof. Next. And last thing is, take care of what you have. It's got a lot of embodied energy in it already. This is a typical air filter for a forced air system. Make sure your gutter's cleaned. Water is the biggest enemy of the house. This is a much older outside air conditioning unit, and you know, it's kind of overgrown with English ivy, so it's not going to operate as well as it could. So keep all this stuff clean and everything will work better. I think that's it.
Hi everybody, how are you doing? I'm Lauren from Sustainable Westchester, and I feel like the order of our presentations was so perfect because you've totally teed me up to talk about how people can really go about doing this work in their homes, existing homes, retrofit. So Sustainable Westchester is a nonprofit organization. We are, and just feel free to keep on clicking through. We have, we're a membership-based organization, so the municipalities in Westchester County are our members, and you can see, hold on that previous slides, you could see that your municipalities, Larchmont, Mamaroneck, all the surrounding communities are members of our organization. So Sustainable Westchester is here to provide resources for you to electrify your home. And when you take a look at the source of carbon emissions in New York State, you can see these two bar graphs here show residential and commercial building energy is the largest source of carbon emissions in New York State. So Sustainable Westchester has structured programs to directly target that. Our biggest program is the Westchester Power Program. That is community choice aggregation. If you live in Larchmont, Mamaroneck, you perhaps are customers of Westchester Power. We have 145,000 customers in Westchester County. And I mention that because when you're thinking about electrifying your home, it's important that the electricity you're receiving is green. If you move on to have your home energy assessment, great. Then you move on, instead of having a fossil fuel-based system, to a heat pump, you're switching to electric heating and cooling. So if you're receiving green electricity to your home and then powering your heating and cooling with that electric appliance, you can really consider yourself 100% fossil fuel-free in your heating and cooling. So that's a really important caveat I like to point out. And we've got resources for you here if you're looking to buy an electric vehicle, change your landscaping practices, participate in grid rewards. If you have questions about recycling, community solar, or what we're going to talk about today, energy smart homes, you can reach out to us, phone, email, whatever works for you. So energy smart homes, I think we're all feeling this. We know the energy that we're using in our home is coming from heating and cooling, and we're all experiencing high electricity costs these days. So it's really important that we reduce where we can. We're here for you. My colleague Lauren is in the back. We're here if you ever need to give us a call, phone, email, and we've got resources in the back of the room as well. We have a contractor partner list, and also we have tried to inventory the rebates and financing assistance that's available. Okay, so the 4 technologies in the presentation that we're talking about today, to pick up on what Judd was talking about: home energy efficiency, air source heat pump, ground source heat pump, and heat pump hot water heater. So we'll go through those. These are our partner contractors that are participating in the programs that NYSERDA, New York State Energy and Research Development Authority, offers, as well as your local utility programs. And we'll talk about that in a couple minutes. Questions? No? Okay. All right. So insulation. Thank you, Judd. You just made me feel so happy to give this presentation, because you are basically like an energy coach. And now I don't have to do any of the technical part of this presentation. I could just tell you some fun facts. So if you think about insulation, definitely, yeah, it's keeping you warm in the winter, but the benefits continue to the summer. If you're cooling your home in the summer and your house is well insulated, it's going to help you keep that conditioned air in your home. It's also going to help make your house quieter. I've had a lot of parents say to me the day after they get their insulation done, they call and they're like, I can't hear my kids screaming from the other room. This is the best part of it. So there's a lot of benefits to insulation. And here's that picture of the home energy auditor with the infrared camera. So if you're wondering, how do you get started with this whole energy efficiency work? You can have a free home energy assessment, but it is through New York State program. There's a lot of checks and balances in place. We have our vetted contractor list, so we really do stand by the contractors that we recommend. And the place to start is the home energy assessment. So you call a contractor to schedule your assessment, and then they'll come out and visit your house and do a series of diagnostic testing. You'll be at the house when they're there, so you can ask them, hey, why is this room cold? Or I've noticed a lot of drafts over here. And they'll be walking through with you, kind of like a home inspection. And then after the assessment is complete, the contractor will come back to you maybe a week or 2 later with a report that summarizes their findings. And then they'll suggest to you where you could add insulation, where you could be doing air sealing work. And for you as a customer in New York State, you're allowed to have as many assessments as you like. You can call up the contractors on the Sustainable Westchester list. You can call the other contractors on the NYSERDA list. Or do you guys do energy assessments? No. Okay. So so there's options, and then you'll want to compare the assessment reports that the contractors provide. Okay, so here's just some pictures of the air sealing, and it's like, well, where did these holes come from in the first place? And you think back to the cable guy drilling a hole, and all these little things are areas that need to be patched up and sealed. So NYSERDA offers 3 different programs for making your home energy upgrade happen. They're income-based, so the average income earner will be participating in the Comfort Home program. It's not so important to know the different names of the different programs. Better to just know the benefits. So if you go through the NYSERDA program, you can get between $500 and $4,000 in rebates from New York State to do things like insulation and air sealing work. There's also financing help available through New York State. There's on-bill financing, so you can pay back your energy upgrade on your utility bill, and you're paying back that upgrade with your energy savings. And the contractors will summarize this for you in the assessment report as well. Okay, and then there's an assisted home performance program, which is another version of Comfort Home, but it's providing an additional $5,000 in rebates up to 50% of rebates up to $5,000. And this is usually for people, the income ranges are listed here on the screen. If you have enhanced star property tax exemption, it's likely that you could qualify for this extra assistance from New York State. And then the 3rd level program, Empower. Perhaps you know someone that is receiving SNAP or HEAP benefits. They could live in an apartment or a house. They can get 100% of their energy upgrade work covered for free, up to $10,000. This is a great program to help relieve the energy burden for New York State residents. So if you know someone that would qualify for Empower, please connect them with us. We can help people with the application. This is a great program to go through. Okay, and everyone's wondering these days, Inflation Reduction Act, I wrote down the number because I can't remember. So what was it? $369 billion was the size of the thank you very much, Inflation Reduction Act. And that money is all going towards helping Americans participate in this movement of electrification, make their homes run on clean energy. So right now, starting in 2023, the tax credits are ready. Yay, so exciting. So 25C is going to be the way that you get into this matrix of tax credits. And we have lots of information in the back. We can step through this with you over the phone and also with your contractor. So as I said before, home energy audits are typically free. For example, on our list, one contractor does charge. So if you come across home energy assessments that are paid, you actually can get that reimbursed on your taxes, 30% up to $150. And the total amount of insulation credit for this year is $1,200, and that credit can be claimed every year, which is kind of interesting if you think about, okay, maybe this year you want to cover insulation of your house. Maybe a year later, you want to do the exterior doors or another piece. So you kind of pick and choose as you please. And then more information is coming out with the point of sale rebates. These have not been set yet. We're waiting for what NYSERDA is going to do. So check back with us at the end of the summer. And also, you can use a great resource called Rewiring America. If you haven't been on the Rewiring America website yet, I highly recommend it. You type in how many people live in your house, your zip code, and it will help you figure out exactly what you may be able to get out of either the homes or HERA portions of the IRA. Okay, so that was a lot about insulation, but that is for a reason. So when you're thinking about making your house more energy efficient, the insulation is really the number one thing that you're going to want to do. Then after that, I'm just checking my time. After that, you're going to think about your heating and cooling. So how many people in this room, by a show of hands, are heating and cooling their home with fossil fuels? Oil, gas, propane. Yeah, so most of us. Who did not raise their hand? Do you want to shout out how you're heating and cooling? Any brave soul? Yeah. Nice. Okay. I guess both. Great example. And that's part of it too. So this lovely lady is heating her house and cooling it. Yeah, both? Good. With air source heat pump. They're also called ductless mini splits. Oh, you have your hand raised? Yeah, I'm about to put a geothermal. We're going to get to that. Thanks for sharing. So air source heat pumps are a much better way to heat and cool your house as compared to the traditional fossil fuel system. We're not cavemen. We don't need to be burning stuff in our homes to keep us warm in the winter. Instead, we could be using electricity to power a heat pump to move air instead of burning it to create heat. All right, so let's just flip through these really fast because I know we're getting short on time. This is a picture of the ductless mini split. If you have an old house and installing ductwork seems like totally something you would never do, you may look to do the ductless mini split instead. And these are great. You have the outdoor unit, can be connected up to 5 units inside. And then if you do already have existing ductwork in your home, you may think about doing a whole house air source heat pump unit. This can line up with, if you already have central air ductwork, this system can pop right in. Or if you're someone that's always been thinking, maybe I really want to get the ductwork for central air, you might as well do an air source heat pump instead for your heating and cooling. All right. And then for air source heat pumps, I think most people in this room are in Con Ed utility territory probably, but we do have NYSEG information if you're from Northern Westchester. Con Ed is offering a rebate up to $8,000 on the air source heat pumps now. And then there are the federal tax credits on air source heat pumps as well. That is capped at $2,000 annually. And then we'll see what happens with homes and HERA. The amounts are set. We'll just have to see how it flows. All right? Now, ground source heat pump for the man in the back that's doing geothermal. Geothermal is a little bit more expensive to do than air source heat pumps, but it's more energy efficient, so it has a faster payback period. Okay, let's see, what's next? Okay, ground source heat pumps, yeah, like we said, lowest operating costs for heating and cooling. And for this, we're thinking about doing a little bit of a bigger project. Air source heat pumps, it's all just on construction on your house. Ground source heat pumps are actually going to be drilling wells. And the wells, people ask, okay, I have a lot of rock in my backyard. I don't think this is going to work. Rock is actually good for digging geothermal wells, and the companies really have amazing drill rigs these days. They are very small and nimble. They can get into a backyard. The wells can be dug in a driveway. There's really, it's amazing to see what's done. So you can call the geothermal companies. They'll come out for the site assessment. They'll survey your land and give you some ideas about where the wells could be dug. And one of the best benefits of geothermal is there's no outdoor equipment. So Jen is standing here, she planted this bush, she doesn't have any outdoor equipment anymore. Oh, that got a little messed up. But the utility rebates, Con Ed is offering $20,000 rebate, and New York State tax credit is up to $5,000. And then we have the tax credits through the Inflation Reduction Act. Again, this is a better one. The tax credit for geothermal is a little bit better than the tax credit for air source heat pump because this is not capped at a certain number. Okay, we'll see what happens with these guys. We already have the number set. And Westchester GeoPossibilities, this is a great tool. The URL is geopossibilities.ny.gov. You type your address into this screen, and then your house will pop up on a map. You could go to the next. And it's going to then give you a calculator, one more, of the savings that you could achieve at your home with geothermal. So it'll tell you if your site is a good spot for geothermal, and then the calculator is a helpful tool. If you do use this site, just remember it's not factoring in the rebate incentives or the utility incentives, so the number on the screen is going to be even better than what they're telling you. Okay, the last technology, heat pump hot water heater. And this is something, maybe it'll be a while until you're replacing your fossil fuel-based furnace or boiler, but more common that you have to replace your hot water heater sooner because those don't last as long. So if you're in the shopping area for hot water heater, would definitely recommend going for the heat pump hot water heater. Much more efficient. This is a unit that's a little bit taller than what people are used to, and even though it's a little bit more expensive than a typical hot water heater, the heat pump hot water heater is 3 to 4 times more efficient, so the payback period is just really incredible. And like you were saying, it provides dehumidification. Okay. If you have your hot water heater in a closet, though, it's not going to be a one-for-one switch, but go for calling the contractor. They'll come out for that site assessment and help you with that. The utility rebates are available, and same with the tax credits. On the next slide, you'll see we've got tax credits from the Inflation Reduction Act as well. Okay, and then we've got this slide again, info in the back. If you're wondering how are heat pumps working in other people's homes, please visit the Sustainable Westchester website. We've got case studies, videos, video tours of people showing us around, and we've done detailed energy usage analysis reports to show the savings that they've achieved. So definitely check that out. And then the last thing in my presentation, if I have enough time, let's see, do I have the time? I have my timer going. Okay, 1 second. Then on the next slide, you'll see if you do one thing leaving this session tonight, I'd say sign up for Grid Rewards. You don't have to do any construction in your home, and it's all about demand response. So are there any Grid Reward used? Wow, woohoo, Larchmont, yeah, awesome. So people are using it. Did you get paid recently? How much do people get paid? 300, wow, that's really good. Cool. So if you just click through, Grid Rewards is a demand response program. You sign up to participate. You get a text message in the summer when it's time to reduce your electricity usage. If you reduce your electricity usage, you get a check at the end of the year. And while it's great to get paid to reduce the electricity, the most important part is you are helping to alleviate stress on the energy grid, reduce pollution in environmental justice communities, and prevent carbon emissions, because you are reducing your electricity usage at peak time when the energy grid is most stressed. Okay, that was great. Any other things here? This is a picture of the app. You can use it year-round. I check the app all the time. It tells you when it's a good time of day to use electricity, when the carbon grid is less energy intensive. So if you're really into saving the environment, you could check the app before you do the laundry or run the dishwasher and see if it's a good time. And it also helps you see, so that's the QR code to download the app. And you can see in the app your usage down to the 5-minute mark. So it's an awesome tool to sign in and understand your energy usage. And that's everything, I think. So thank you. Oh, and if you have more information, we're having a session February 16th on Zoom, talking with our assemblyman and state senator, going through Inflation Reduction Act stuff. So thanks, everyone.
I'd like to thank all of our speakers. And before I turn to the Q&A, I would like just to say that we here at Larchmont Temple are thinking of participating in the grid rewards, so we're going to hopefully be part of that effort. And that would be a synagogue-wide effort that we will initiate. I think we'd like to turn it over to Q&A, so you're going to do that? Wait for the microphone, okay? Thank you, Liz.
Thank you. This was wonderful. Much appreciated. I am a new apartment dweller, so I can't use all of these wonderful tips at home. And I'm interested in knowing, I was looking at it with things that I could do in my own apartment, but are there websites or information on how to do things in an apartment by the condo or the other kinds of types of residencies?
Can access, is it working? Yeah. Oh, okay. It can access a flex tech or a green jobs, green New York energy audit. So lots of stuff that the building itself could do. There's some great carbon reductions to be found there. And as a tenant in the apartment, it's important to make sure your electricity usage is green and you can participate in grid rewards.
I don't have any clever advice, but I did just want to say that, you know, living in an apartment is an inherently much more energy efficient lifestyle than living in a single family home. So congratulations.
Question here.
So this may be a little bit of a tangent from what you were talking about, hopefully not too much, but I have been hearing nothing but the evils of gas stoves the last few months. And I'm just wondering if you have any or all of you have thoughts on going from gas to electric induction, et cetera.
I'll just say, you know, the big issue with gas stoves is less about energy consumption, although whatever, there is some, but more about occupant health. The more we learn about kitchen and cooking and gas stoves in particular, it's amazing how bad they are for occupant health. But I will just say, in terms of energy usage, I mean, I haven't run the numbers. Induction stoves are fantastic. They're very energy efficient. I've used them a few times, and they're wonderful. But I don't know that you're going to, I don't know, maybe Lauren, I don't know how much energy you're going to save by doing it.
Yeah. So we have a house in Vermont, we have a house in Larchmont, and because of the passive house that we're trying to do, we went with the full induction. And we'd had the induction in Vermont for 10 years, but we're only up there every couple of weeks. I find that the control for cooking is awesome. Like, I know exactly when I'm going to burn something. I know when I'm not going to burn something. My wife likes to look at gas and see how high the flame is, walk away and burn it. So I don't get it, so we have this argument all the time, but she is all on board for it. We're not going back. Easier to clean. I mean, you can use that as another part of your kitchen. You don't cut anything on it, but it becomes inert. Like, all of a sudden, it's no longer going to drop things. So aesthetics, there's a lot of really good reasons, I think. My electric bills are pretty high because we're 100% electric. So, and we're about to go geothermal. We have a heat pump, but we're going to go geothermal at some point soon. And then we'll see, it's probably going to go higher. So, that's all I got.
Having the gas stove in your kitchen is kind of like running a car in your kitchen. The noxious chemicals that are emitted, it's not like the gas stove chemicals stop when the stove is not on. It's always leaking because that pilot light's on. So definitely using an electric stove, an induction stove is the healthier and safer way to go. Studies have even shown that kids that live in homes with gas ranges have asthma at a higher rate. So.
I'm one of them.
Really?
Oh, yeah.
Wow.
Is this working? Yes. Can you please talk about the concern that it might be a problem if you put in a few passive house or tight house or pretty good house things, but not all of them? Like, for example, I have an old house. I was thinking about putting in insulation, and we were told, oh, wait a minute, if you're not careful and you don't have vapor protection, you could end up getting mold. Oh, wait a minute, if you put in air barriers and if you make a really tight house and you don't have air circulation, then that could be bad too. I mean, maybe a little bit of knowledge is a dangerous thing, or not enough knowledge, of course, is a dangerous thing. But what do you do? Do you have to have the whole package, or is one piece okay? Am I making sense?
That's how you look at it. The house is a system. So, sorry, your home is a system. Your home or your apartment, wherever it is a whole system. So you bring your insulation people, you bring your HVAC, you bring all these people in and look at it critically. That's my experience.
How old is your house? Yeah, you don't really have to worry. It leaks so much air already. Even if you take all the steps that I showed there, it's going to leak a lot of air. If you insulate with blown-in cellulose, like I showed in that slide, that's very forgiving insulation in terms of absorbing moisture and expelling it and things like that. So if you don't have cellulose in the walls already, I would do it. I think you'll be just fine.
And I always, when we're working on an existing house, I always say get an energy audit first. A good energy audit will give you a roadmap and will show you, this is, first of all, this is what will have the most impact on your house in terms of energy savings, and it will sort of lay out the steps to take and which ones to go first. So it's great. And NYSERDA is living in Maine, I'm very jealous of NYSERDA, and Massachusetts has a great program. So, take advantage of NYSERDA. You're lucky to have it.
Hi. I have a comment and a question. The comment is, it's a wonderful talk. I couldn't keep up taking notes. one comment, I don't recall whether you mentioned anything about two-zone heating. I know at home when we built an addition, our upstairs has a different heating system. And now that my children, nobody's living up there, I can keep that very low. Second, a question. I'm part of a summer community. It's a cooperative. It's in Westchester County. We do not have individual meters. How can we take advantage of some of these programs?
Yeah, so if you want, I can connect you to my colleague Rachel Carpatella. She is the Commercial Clean Heating and Cooling Director at Sustainable Westchester, and she can walk you through how the building could get started on a building-wide energy audit. That's the first step. Building-wide, yeah. So we would work with like your maintenance crews, your facility managers on a larger scale.
Sounds like this is multiple houses on a single meter?
I'd say they're unheated cabins. Oh, sure. And the social hall is huge and electrified.
Yeah, so let's talk more in the back.
Thank you.
Right.
I'm just going to allow one more question, and we'll end because we are committed to ending at 5:30.
Okay, I don't know how important mine is. If someone has a super important question, you want to jump in? I've heard about some alternative insulation options like jean fabric. Have you guys ever worked on anything like that? And what do you think of that versus something like cellulose? Or what is your favorite, best, most environmentally sustainable insulation product that you would recommend? Cellulose.
And the cellulose can have the jeans in it. I have some in my car. I should have brought some in. When you look at the blown-in cellulose, you could see bits of newspaper, and sometimes you could see the fiber of the jeans as well. So. And classified documents.
Yeah, it's, I'm with, I mean, there's a lot of benefits to cellulose. I'm happy that there's some building science-y benefits to cellulose as well, that, you know, they hold and distribute moisture in a way that is good for the building, and anyway. I'm excited for this product that I was talking about before too. Yeah, but Rockwool is, there's nothing environmental about Rockwool.
I just had a follow-up question about insulation. I'm building a house in Massachusetts, and I'm looking for an alternative to spray foam. And I was looking at Havelock wool, and I don't know what your thoughts are in terms of it being effective. I know it could be very expensive, but it has to be like an R factor of like 49 in the roof, so pretty high, and 21 in the walls. I know spray foam is very, I guess, a cost savings in terms of that. A cost savings perspective it's very high, but I don't know health-wise in terms of the chemicals that are used, in terms of while it's spraying and how long you have to be out of the house, and then later on when you get rid of the house, how good the spray foam is to the environment, and I have concerns about that.
My basic attitude in new construction is there's really no reason to use foam above grade. There's always better alternatives. When I build new houses, pretty much my standard wall section is two individual walls that are, you know, that are about a foot thick total. There's about 5 inches in between, and we dense pack that with cellulose. You know, do you have a builder you like already? Yeah, I mean, the most important thing is to lay out your priorities, but there's a lot of resources out there. In fact, I wrote an article about double stud. I'm happy to give you the link to it, but yeah, it's easy to get rid of foam above grade in new construction, and you should.
Is your builder on board with what you want to do? it makes for a big, thick roof, but there's an organization, Northeast Sustainable Energy Association. If you look that up, there's a listing of contractors, and Massachusetts probably has more NESI, Northeast Sustainable Energy Association members, than any other state in the Northeast, and there are many, many well-qualified and committed contractors listed there. So I would go there.
Well, I just wanted to say thank you so much. Some of you guys traveled far to be here, Maine. And to our speakers, thank you guys so much for coming. If you have any questions, we have their contact information. And also, we've recorded the presentation, and we will make it available to the public. Also wanted to thank Reverend Lisa Mason and Reverend Tammy Burks for coming today, and Larchmont Temple for hosting this great talk. So
Feel free to share my PDF with anyone who wants it.
Okay, great. Great. Thank you. Thank you.